Now the next thing that we'll study in sequences is Cauchy sequence. Now Cauchy sequences are also called as fundamental sequences. Now first we look at different definitions of Cauchy sequence. Now the first definition is a sequence Fn is said to be a Cauchy sequence if for any epsilon greater than 0 there exists a positive integer m such that Fn minus Fm mod is less than epsilon for all n greater than or equal to m. Now what we can do is we can write this definition in two equivalent forms, and the first form is for any epsilon greater than 0 there exists positive integer m such that Fm plus p minus Fm is less than epsilon for all p greater than 0, or we can say a sequence Fn is said to be Cauchy sequence if for any given epsilon greater than 0 there exists positive integer m such that Fp minus Fq mod is less than epsilon for all pq greater than or equal to m. Now there are two theorems on Cauchy sequences that we need to know, and the first theorem is every Cauchy sequence is a bounded sequence, and the second theorem is Cauchy's convergence criteria, and we are more interested in this, and it says a sequence of real numbers is convergent if and only if it is a Cauchy sequence. So every Cauchy sequence, it is a convergent sequence and vice versa. Now let us take an example. Say for example, we need to show that Fn, which is defined as minus 1 to the power n upon n, is a convergent sequence. Now we'll write mod of Fn minus Fm. Now Fn is minus 1 to the power n upon n, and then minus Fm is minus 1 to the power m upon m. Now this expression will always be less than or equal to 1 upon n plus 1 upon m, and if n is greater than m, then it will be less than 2 by m. Now Fn minus Fm, it is less than epsilon, then this m, it will be greater than 2 upon epsilon. So for any value of epsilon, however small it may be, we always get a value of m where n is always greater than m. That means the sequence Fn, it's a Cauchy sequence, and Cauchy convergence criteria says every Cauchy sequence is a convergent sequence. So the sequence, it is a convergent sequence. Now the next question is, using Cauchy's general principle of convergence, show that the sequence Fn is not convergent where Fn is 1 plus 1 by 2 plus 1 by 3 up to 1 by n. Now again we'll find mod Fn minus Fm. Now Fn will be 1 plus 1 by 2 plus 1 by 3 up to 1 by n minus 1 plus 1 by 2 up to 1 by m where n is greater than m. Now here 1 by 2, 1 by m will cancel. So we'll get this as 1 upon m plus 1 plus m plus 2 up to 1 by n. Now if we choose this n as 2m, we can write this as 1 upon m plus 1, 1 upon m plus 2, 1 upon 2m will be greater than 1 upon 2m, 1 upon 2m, m times. So it will always be greater than 1 by 2. So Fn minus Fm, it is greater than 1 by 2. Now this contradicts the condition of Cauchy's criteria. So the sequence is not convergent and it is not a Cauchy sequence.